In an aquaponics system, the waste produced by your fish becomes the exact organic fertilizer needed to grow vegetables. As the plants absorb those nutrients, their roots filter and purify the water, sending it back to the fish. The goal here is to establish a balanced, small-scale backyard ecosystem that consistently yields fresh produce while keeping a healthy population of fish year-round. To start, this graphic shows the baseline equipment you will need: a reliable water pump, a water chemistry test kit, porous grow media, your chosen plant seeds, and the fish themselves. Mastering the specific balance between these physical and biological components turns separate parts into a single, automated food-producing engine. The most common point of failure for beginners is stocking too many fish for the volume of plants they are growing. This overloads the water with waste and causes fatal ammonia spikes. To prevent this, we use the 50-8 rule. Exactly 8 square feet of grow bed, filled 12 inches deep, safely filters 50 gallons of fish tank water. Inside that tank, the safe biological load limit is exactly 5 to 10 small fish. You have two main options for livestock. You can raise hardy ornamental fish like comet goldfish, which produce excellent fertilizer, or you can raise edible warm water species like tilapia. Strictly adhering to this volume to biomass ratio prevents toxic chemical buildup and keeps the system from crashing. Next, we configure the grow bed. The inert grow media inside serves two distinct purposes. It physically anchors the plant roots, and it provides massive surface area for the nitrifying bacteria that process the fish waste. For a cost-saving dual-layer strategy, fill the bottom half of the bed with cheap, porous lava rock and top it with smooth, expanded clay pellets. When the pump is running, the water level inside this active grow bed should rise to exactly 1/2 inch deep, ensuring the upper roots have access to oxygen. You can calibrate the pump's flow rate by dropping a small stick in the water. As this test shows, you are looking for a steady flow where the stick travels about 12 inches in 30 seconds. Pairing maximum media surface area with this exact steady flow rate guarantees the biological filtration needed to process the fish waste. Before planting, you must start your seeds in an external nursery. Putting soil directly into the grow bed introduces pathogens and muddies the clean aquaponics water loop. Next, map out your plant density. Small leafy greens allow aggressive spacing of 20 to 25 heads per square meter. Conversely, heavy fruiting plants require wide spacing, but their shade can protect smaller, shade-tolerant greens between them. Strict spatial mapping maximizes your overall crop yield without exhausting the limited nutrient supply generated by your fish. You can identify when a seedling is ready to enter the system by counting the leaves. Wait until it develops 3 to 4 true leaves. Prior to insertion, gently and thoroughly wash all the dirt away from the root systems. Always transplant at dusk. This time-lapse demonstrates how the twilight window shields vulnerable roots from midday thermal stress, allowing the plant to acclimate overnight. Eliminating mechanical soil contamination and thermal shock during this brief window dictates the baseline survival rate of the entire crop. With the system running, you must establish rigid daily routines. Limit daily fish feeding to 1% to 2% of their total body weight. After 30 minutes, you must remove any uneaten food from the tank. Leftover matter will decompose rapidly and foul the water. Observe your fish while they eat. Look for straight tails, extended fins, and an aggressive appetite to confirm they are stress-free. Weekly, you will test the water chemistry. This dashboard interface tracks your targets. Alongside your feed limits, your pH needs to stay locked between 6.8 and 7.0 to keep both the plants and bacteria functioning efficiently. Rigid adherence to this 5-minute daily observation routine is the only reliable method to preempt invisible, catastrophic chemical crashes. When leafy greens reach maturity, you must extract the entire plant from the bed, including the complete root mass. Leaving dead roots behind creates compounding dangers. They rot, spread disease, and physically clog the water flow through your media. You also need to maintain system equilibrium by using a staggered harvest. This 4-week calendar outlines a fractional row replacement, where you only swap out a portion of the plants at a time. Staggered fractional harvesting prevents sudden nutrient spikes, ensuring the fish are never stressed by abrupt chemical shifts in their water. Setting up an aquaponics system requires precise volume sizing, calibrated water flow, and strict staggered biological routines. But as we rise from the fish tank up to the canopy, you can see the result: a perfectly balanced, fully realized closed-loop ecosystem. If you're ready to build your own, hit subscribe and let me know in the comments below which specific species of fish you intend to raise. Home aquaponics is the successful engineering of a living, breathing cycle.